Hello everyone, welcome or welcome back again to another video tutorial from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and in today's video we're going to be continuing from our previous uploads that we've been making here on past paper solutions. Primarily here we're focusing on the 2024 January RESIT exam paper that was most recently concluded around, say here, January the 5th. So of course on our two previous uploads we had looked at questions 1 through to 6, and you can see here that we're in fact going to be wrapping up the entire paper here, and we're going to be going through questions 7, 8, 9 and 10. All right, and particularly what I want to really focus on is assisting students, well, at least my level of students that are currently attacking the exam. I want to develop your level of analytical thinking as opposed to trying to run through the paper. I want to walk you through the whole thought process of how to approach questions that you're currently seeing and questions of similar nature. So of course, if this is the first time here on the channel, do not forget to hit the subscribe button below, turn on your post notification bell, leave some positive questions and comments down below. Of course, leave your suggestions as well to how I can make more and better contents for you. And of course, do not forget to hit the like button. It really does help the channel to grow. All right, so without further ado, we're going to dive on right in and we're going to wrap this paper up, say in about an hour or so. All right, so here we go, let's get it. Now here we're looking at question number 7 here. It says that the diagram below shows the first 3 shapes in a sequence which forms a pattern. Each shape is made using a set of small white counters and black counters. So as we look at this diagram here, let's see if we can figure out the pattern that's going on here. We see that we have in this first shape here, we have 1, 2, 3, 4 shaded counters here, and then we have 6 white counters. Then comparing this here, we're looking at, it seems as if an extra row of 5. So we had 1, then we had 3, then we had another row, but we increased the previous row by 2. So this is 1, we increased this row by 2, so we got 3, then we increased this row by 2 again, so we end up with 5, and then so forth. Then we look at the shape 3 here, we had 1, then we increased this row here by 2, so we got 3, increase this row by 2, we got 5, then again we increase this row, then we end up with, say here, increase this row here by 2 more, so we end up with 7. So now picked up a little bit of pattern here. So complete the diagram below to show shape 4. So that means if shape 3, if the last row in shape 3 had 7, and apparently each time we add a row we are increasing by 2, then it means that this row here, this row that was 7, this next row here is going to be 9. So I guess we're gonna have to say here, shade these circles here. All right, so that's gonna be 7 circles, but we're gonna have to add an extra 2 here and 1 here, and then just fill out the space here and here. Okay, and then of course in this here we had 4 rows of white, so now I guess that we have to have, say, another row down here like that. Okay, all right, so each row increases by an extra 2, so that looks to be the particular shape that we should have. All right, so we had 2 white rows here, 3, then we had what, say here, 4, so more than likely then we're gonna have 5 white rows, so we're gonna have, say here, 1, 2, 3, 4, so we're gonna have another row like that. Okay, Right, so now we end up having, say here, 1 2 3 4 5 rows of black, and we have 1 2 3 4 5 rows of white, because here we had 1 2 3 4 rows of black, and we also had 1 2 3 4 rows here of white. We had 1 2 3 rows of black, we had, say here, 1 2 3 rows of white. So we have 1 2 rows of black here, then we have 2 rows of white. So there's many ways to look at different patterns in this, say here. So I guess this would be it. So we'd have to have this extra row here shaded, then we would definitely then have to have 2 extra rows at the bottom and fill out the space. So this, I'm assuming, would be the diagram that Csec is asking for. All right, so that's a nice 2 marks there. Hopefully you guys got a hang of that. Now it says here that the number of white counters W and the number of black counters B and the total number of counters T that forms each shape follows a particular pattern. All right, so the values of W, B, and T for the first 3 shapes are shown in the table below, which you're seeing here. There's a bunch of sequence here that we need to study. So the we should study the pattern, right, of numbers in each row of the table and answer the questions that follow. So we are to complete the rows marked I, and I in the table below. All right, so let's see if we can pick up a pattern here, guys. Let's see here. Looking at this, it seems as if there's a couple of numbers that are repeating itself. See here, we have 1 2 3, which seems to pretty much matches the numbers over here. That's the first thing that I saw. I also see that this 1 is repeating itself as well, and I also saw that this 2 is also repeating itself as well. And then see, we have this 1 2 and 3, which represents, say here, the shape numbers S. So S seems to be in this column of numbers coming down here, and S again seems as if it's coming down in this column here. We also have repetitive ones here, and clearly then when we work out what is in the bracket, we are getting the answers 6, 15, and 28. So we have 4, so we need to fill out this space here. Let's take a look at the pattern. We have S repeating itself again here. We have this 1 2 and 3, which reflects over here, and here. And then we have this repetitive 1 here, and we have it all squared. And then we have 4 9 16. These looks like square numbers, so that's 2 squared, 3 squared, 4 squared. So all right, seeing some patterns here. All right, this is kind of like what you guys need to do when you're on the exam paper. You've got to try to figure out what numbers are repeating, what numbers are connected, which row is connected with which numbers. You need to be familiar with certain types of numbers. Like immediately here, as I look, I saw that 4 9 and 16 were square numbers. So that's something that you guys are gonna have to do when you are actually on your own exam paper. You've got to figure out a certain type of pattern that's arriving here. So let's see, how would we have gotten this 10 24 and 44? It kind of seems like if I add 6 here to 4, I'll get 10. And let's check to see if it's consistent. 15 plus 9, it looks like 24. And 28 plus 16, looks like 44. All right, so then I know for certain that whatever number goes here is going to be equal to this number here plus this number here. So it looks like the number of white counters plus the number of black counters gives us the total number of counters, which is kind of obvious. So we need to try to figure out, see what goes here. So if we notice here that 1 2 and 3 is following over here, 1 2 and 3. So if this is 4, this is going to be, say here, 4. And then we know, of course, it's going to be a plus. The 1 repeats itself, so the 1 comes down. And then we're going to square this. could almost guess that this is 25 because it's following the square pattern. 2 squared, 3 squared, 4 squared, 5 squared. So that's 4 plus 1 is 5 squared. Gotcha. And then of course we're gonna add 45 to 25, and that basically will give us a result here of 70 there. All right, so we know that for certain. Now since we know that whatever number is here adds to this to give us 420, we can easily then say that this missing spot here is going to be 420 minus 144. So 420 minus 144, that will give us, say here, 276. Okay, so that's going to be 276. That goes here. And then now to figure out which number goes here, we know for certain that this is a square number. So we know that if we think about this for a second, we can actually take away the 25 here from the 144 because we're trying to find the number that goes here. So if I subtract, let's say I take 144, which is this number here, minus the number that we had way before 144, that looks like, let me see here, that's going to be 144 minus 25, that gives us 119. So that doesn't look too good there. So that's not going to be a good number. I know that 4 plus 1 is 5 squared, so it's going to be, maybe it is going to be 11 plus 1. Because see, if this is 4 and we add 1, then I know that 144 we know for certain is 12 squared. That's what we know for certain. But to get the 12, obviously because we had to add 1 to a number, this most likely would have had to been 11 plus 1 squared. So that would have had to be, for here, just thinking about the pattern, this would have had to be 11 plus 1 squared. That would have given us, say here, 12 squared, which is 144. All right. So we know that that's 11 plus 1 squared. And if we notice then that the number here 1, 2, 3, 4, they're coming from over here 1, 2, 3, 4. So if this is 11, then that means this is going to be, say here, 11. That's kind of like the way that I thought about it. All right, let me know if you guys saw another way that you could actually figure out that the answer is 11. All right, and then now we gotta figure out, say here, this is the most challenging part that I've seen in these types of questions that Csec sends across. So you have to try to figure out what is the pattern here of the equation using, say here, n. N is what we're going to be using. So n now is actually representing, say here, n here is representing the number or the shape number. All right, so we know for certain that the shape number is repeating itself. So that's 1, 2, 3, 1, 2, 3 is repeating. That means then that this n here is going to go right here because that number is repeating itself. So that's n right here. All right, and then of course we know that 1 is repeating itself, so that's n plus 1. All right, and then from there now we know that 2 is repeating itself right here, so it's going to be 2. Let me just write it here, this as n plus 1, right? And then we're gonna have multiplied here by, well, 2 brackets here. We're gonna have 2n, right? That's gonna be 2n because see the 2 repeats itself, and this you see here 1, 2, 3, and that's 1, 2, 3 represents the n over here, so that's gonna be 2 times n plus 1. And then we close off the bracket there. So that is for that section. Then so we're just following a pattern all right? And then of course we're gonna have, say here in this, we're gonna have 11. So whatever number is over here is also over here. So this is going to be n plus 1 squared. So that's n plus 1 squared. And so obviously then when we distribute this and distribute this and add them together, then it obviously gives us whatever Csec has given us here, 3n squared plus 5n plus 2. All right, so there we have it. Nice little pattern here. We've figured that one out. Let's go down to here. The expression for the total number of counters, T is equal to W plus B in shape S is given by, say here, the formula T equals A S squared. Oh, let me just remove that bracket then. Okay, let's just remove the entire thing here. So that's A S squared plus BS plus, so that's BS plus 2. All right. Now, it says where A and B are both positive integers. Now, it says by substituting suitable values for S, show that the total number of counters in shape 1 and shape 3 in terms of A and B is represented by the equation. So we have to prove this equation here. Now, let us first just look at, say here, shape 1. So shape 1 then, using the formula, we know that we know that the total number of counters in shape 1, if you go back on our table here, total number of counters is 10. So we know that T here in this case is, say here, 10. And then of course that's going to be equated to A open bracket, say here, S for shape 1. S then works out, say here, easily to be 1. All right, so that's going to be 1. Scroll back down here, so that's going to be 1 squared. And then of course we know that B is going to be left there, and S again is 1 plus 2. All right, so if we simplify this, then we have 10 is equal to A times 1 squared is 1, so that's 1A. And then of course we have 1B, and that's going to be plus 2. And if we fix this equation up, then we can therefore then go ahead and say A plus B, so that's 1A plus 1B. I'm going to bring this positive 2 over to the left side, so we're going to end up with, say here, 10 take away 2. So then easily then we end up, say here, with 8 is equal to A plus B. It's kind of written backwards, but okay, that's fine. That's A plus B is equal to 8. So we have basically proven this part of the equation. We need to prove the next part then. So the same here, but this time we're looking at shape 3. So that's T is equal to the same procedure here. That's A, sorry guys. So that's going to be A S squared plus BS. Let me see here, BS plus 2. So now we're looking at shape 3. Then we know that the total number of counters in shape 3 is in fact 44. Okay, so let's scroll back down here. That's going to be that 44 is equal to, again, A is here, and then S now, that is in shape 3, we know that that's going to be, say here, 3. So that's going to be 3 squared plus 3S plus 2. So 44 is therefore then equal to 3 squared is 9, so that's 9A, and 3 times, say here, S is 3. Did not write this one properly, guys. I think this is going to be, say here, so this is A times 3 squared, and that's going to be equal to b times 3. That's what I had here. So that's going to be plus 3b, and that's going to be plus 2. All right, so if we go ahead then and we say here 9a plus 3b, we're going to bring this 2 over here, so we're going to end up with, say here, 44 take away 2, because we transpose this 2 to the left side. So we end up with 9a plus 3b equals 42. And so we have a divisible factor here of 3. So if we divide, say here, the whole entire equation by 3, then dividing 9 by 3, we end up with 3a. Dividing 3b by 3, we end up with b. And if we divide 42 by 3 here, we end up with, say here, 14, which basically proves this equation here. All right, so that's what we had to go through. It's a lot for 2 marks though, but that's the process of simplification then. So we end up proving both equations then. All right, so as we scroll down here then, I think that is it. That is the end of the question. I figured that maybe they would have asked me to solve for A and B, but that's fine. They didn't ask us, so that's the end of that question. All right, so that was not a bad question at all. Pretty easy when you stop and think about it. So let's then move on then to section 2. Now we're going to wrapping up questions 8, 9 and 10. So in section 2 here, we're to answer all questions. The first topic here is going to be algebra, relations, functions and graphs. The diagram below shows the graphs of 2 functions on the same pair of axes. The lines G and H are perpendicular. We need to underline that word because that's going to be key later on. Now, it says here that we're to determine the equation that represents the line G. All right, so we're looking at this particular line here, line G. So what this means for me then is that what I'm thinking about here is the very first thing is that y is equal to mx plus c. That's what I know for certain. Now, you could do a couple of things here. We could actually write down the coordinates of this point here, and we could write down the coordinates of this point here and use the formula m is equal to y2 minus y1 over x2 minus x1. So we could do that. We know that this position here would have actually been, say here, negative 6, 0. And then this position here is going to be, say here, 0, 3. So I know that this position here is going to be 0, 3. All right, you could use coordinate values, but I particularly feel like I want to just do something a little bit different here. Since as the points are not generally on a graph paper here where the points are easy to read, many students may not see it that way. Another way that I'm thinking about here is actually using the formula rise over run. So rise here divided by run. And so how we can find the rise is the mere fact that if we go on our graph here and we look at the point G, here's a point right here and here's a point here, I could just use this as my rise and this as my run. So my rise here would be negative 3 coming down. It's negative 3, and my run would have been, say here, negative 6 because I'm going towards the left. So coming down, rise, negative 3, run, negative 6. So it works out that my gradient here is a half. But say for argument's sake that a student does not see it that way, then we could use, say here, y2 minus y1 over x2 minus x1. And so because, of course, for the student who recognizes that they could actually write down the points, then we know that one of the points is in fact minus 6, 0, and then the other point is 0, 3. So we could go ahead then and label our points then as x1 y1 and x2 y2. So just looking at both options here, guys. So then what we're looking at then is, say here, y2 is 3 minus y1 is 0 over x2 is 0, take away x1 is negative 6. So therefore we end up with 3 take away 0 is 3 and 0 take away negative 6 is 6. So that still works itself out to be equal to a half. All right, so you guys can determine what method you want to use to find your gradient. I particularly just encourage my students that I've taught over the years that once the question presents itself graphically and you can see some sort of intersecting points on the axis, you can therefore then go ahead and use rise over run. All right, so in this case now, I know for certain that m is equal to a half, and we know also that c is referred to as the intercept on the y-axis. So this is the point at which that particular line crosses the y-axis, and if you look good here, you'll recognize that the actual line passes the 3 here on the y-axis. So I can therefore conclude that my equation then is y equal a half x plus 3. That's the equation for line G. All right, so a little bit of thought had to go into that. That's how you're going to approach that particular question then. All right, now let's move on then to looking at the equation of H. Now they did say something up here, and they said that the lines G and H are perpendicular, and as you can see, I've underlined the word perpendicular because now to find the equation then of, say here, the line H, we know that if two lines are perpendicular, let's just write that down. So if two lines are perpendicular, then we know that m1 multiplied by m2 equals minus 1. So we have to determine the gradient of H because H is perpendicular to, say here, G. Now, since we know that the gradient of G is actually a half, then we can just basically solve this equation for m2. So therefore then m2, then if we divide both sides by a half, we end up with negative 1 divided by a half, which works out that m2 then is equal to minus 1 multiplied by 2. So it ends up then that m2 here, which is the gradient of H, is equal to negative 2. Now, you didn't have to go through all of that just to get m2. The rule is that you could see negative 1 divided by 1, sorry, negative 2 then divided by, say, a half, because of course the perpendicular gradient formula is minus 1 divided by m1. So you could just simply see negative 1 divided by a half, which basically goes into this, say here, negative 2 times. So you could have done that, or as some teachers will say, you turn the original gradient upside down and change the sign. So that's how you'd end up with the gradient of H. Remember that because H is perpendicular to G, that is why we had to do all that work. So now again, you have to also pay attention to where does the line H crosses the y-axis. So you can see there that we can't really see where it crosses the y-axis because we don't know, there's no numbers here for the line H. So now what we do know for certain is that it crosses, this position here is a point on the line. This position here is going to be 4, 0. So this is basically our x and y value because it's a point, it's the x-intercept, but it is also a point on the line H. So we could go ahead then and use the formula, say here, we could go ahead then and say y equals mx plus c. Since we know that the point where it crosses, or a particular point on the line, is in fact 4, 0, then we know that if it's 4, 0, then that means y is 0, and we know that the new gradient is minus 2 and x is 4, so that's going to be plus c. So therefore 0 is equal to negative 2 times 4 is negative 8 plus c. We can therefore then confirm by transposing the negative 8 to get positive 8. We can therefore confirm that the line h crosses the y-axis at 8. So you can see then if you look at the graph and you were to like somewhat project it, this is 3, maybe 4, 5, 6, maybe up here would have been, say here, 7 and 8. So it sounds logical, it sounds reasonable. All right, so therefore our conclusion then is that the equation of h is y equal negative 2x, say here, plus 8, and that is it. That is the equation of the line h. All right, so a lot of thought went into that. Again, as I said, guys, when I'm doing the paper, it is not particularly for me to run through the paper. I could actually run through the paper within less than an hour, but I want to give you guys a chance to understand the live thoughts that goes on into figuring out these questions. Then now we're looking then at, say here, the coordinates of P. So if we looked here at the coordinates of P, let us locate where P is. It seems as if P is the intersection of two lines. All right, so P is actually the intersection of the line G and the line H. So when two lines intersect, in order to find the point of intersection, we're going to have to solve the equations simultaneously. So therefore then, the equation, say here, of the line G, we had calculated to be y equal a half x plus 3. So y equal a half x plus 3, y equal a half x plus 3. I can just rewrite that a little bit better. Let's just write this as, let's just multiply everything here by 2. So if I multiply this by 2, I'm going to get 2y. If I multiply this here by 2, the 2 is going to cancel. So I'm going to end up with, say here, x. And if I multiply here by 2, I'm going to end up with, say here, 6. Kind of want to get rid of that half here. So if I kind of organize this a bit better, I'm going to end up with x take away 2y. So I'm going to carry over the 2y here, and then I'm going to carry over the 6 over here. So that's x here. Bring over the 2y, negative 2y, bring over the 6, I get minus 6. That then becomes equation 1. All right. And so I kind of like when my equation is looking more simultaneously than anything before. Okay, so I kind of prefer x, then y, then my constant on the right. Then my last equation here, we have it as y equals, say here, negative 2x plus 8. Kind of want the x first, so I'm going to fix this up and I'm going to say negative 2x, bring the y over here, I'm going to get minus y, and bring the 8 back over here, I'm going to get equal to negative 8. So I have this equation here, negative 2x minus y is equal then to negative 8, and that becomes equation 2. All right, now once I have this, then I know that the objective then, as we said in part 1 of this video, of this solution paper, we need to try to equalize the middle term here. So I'm going to multiply this equation here by, say, 1, and I'm going to multiply this equation here, say, by 2. All right, so once I have that, then I could multiply by negative 2 and add the equation, but I'm going to just work with the rules that I've given you on my channel. Do check the link pinned in the comments for my simultaneous equation video, so you can master this as well. So then multiplying top equation by 1, I'm going to get the same equation. That's x minus 2y, and that's equal to, say here, negative 6. And then I'm going to multiply here the bottom equation by 2. I'm going to get negative 4x minus 2y equals, say here, 2 times negative 8 is negative 16. Now, since the terms in the middle have the same signs, I'm going to therefore then subtract to eliminate. So I'm going to subtract here, and subtract here. So 1 take away -4, that's going to give us, say here, 5x. And of course, these two are going to cancel. And then -6 take away, say here, -16, that's going to be equal to +10. All right, -6 plus 16, that's +10. Splitting the product, then we end up with x is equal to 10 divided by 5. X works out to be, say here, 2. All right, so that's one of our solutions. And then finally, then we end up with just writing a statement here. We're going to sub to 4x, and we can choose whichever equation, 1 or 2. I'm going to just use, let's do, it doesn't matter which one I choose here. I'm just going to use, say here, equation 1. I could just go right up here and just use this one, this original equation, or I could use this one, it doesn't matter. I'm just going to use this one right here. Okay, so I'm going to have y is equal to 1/2 multiplied by x we now know is 2 plus 3. So y then is equal to 1/2 of 2 is 1. 1 plus 3. It then works out that y is equal to, say here, 4. All right, beautiful. This was a really, really nice question. This is like, from the whole entire paper, this is the second time that I've seen where CXC has definitely really put a number on the application of simultaneous equation in this paper. All right, earlier in part 1 we had a really, really nice worded simultaneous equation that was mixed with a bit of geometry. Now we're seeing here simultaneous equation being mixed with coordinate geometry. So CXC definitely came with the goods this time around. So that was a really, really, really nice question there. All right, now we're going to be moving on to this part of the paper. Then we're going to be writing, say here, 4x squared minus 24 plus 31 in the form a open bracket x plus h all squared plus k. Now this is what we refer to as completing the square. Unfortunately though, I do not have a tutorial on this, but I will be making one in the very near future. But for now, the shortcut in completing the square here is, of course, we need to find the values of a, we need to find the values of, say here, h, and we need to also find the values, say here, of k. And so this is actually a really renowned formula here, where we know that the value of a here is in fact always going to be the value that is right here in front of the x squared. So the value of a here is going to be, say here, 4. H has a formula which, if you know it, you'll realize that h is equal to b divided by 2a. That's the formula. So b is going to be the number in the middle here, because of course, if we know a quadratic equation, you'll remember that quadratic equation is in the form ax squared plus or minus bx plus or minus, say here, c. So already we know that b is -24. So h here is equal to -24 divided by, say here, 2 multiplied by a. In this case here, we know is 4. So that's going to be h is equal to, say here, -24 divided by 8. So happens that h is equal to -3. Beautiful. Beautiful here. And then now we have a formula, say here, for k. We're going to end up with k being equal to 4ac minus b squared over 4a. I will make a tutorial later on of how we derive these formulas. Actually, it is by completing the square on ax squared plus or minus bx plus or minus c that produces the quadratic equation x equal minus b plus or minus the square root of b squared minus 4ac all over 2a. So by completing the square on the quadratic formula, the quadratic expression format, it ends up that we produce these results here. But for now, guys, I just recommend here that you simply remember that h is equal to, say here, b over 2a, and k is equal to 4ac minus b squared over 4a. Once you can remember that, you should be okay. So therefore then we're going to go ahead then and say k then is equal to 4 multiplied by A is 4 multiplied by C here is 31 minus B is in fact negative 24 squared, and that's going to be all divided by, say here, 4 multiplied by A, which is, say here, 4. All right, now when we do some mathematics here, we end up with 4 multiplied by 31, and that is equal to 496. And then we're going to subtract here. When we square 24, we're going to get 576, all divided by 4 times 4 is 16. So 496 minus 576, we end up with, say here, negative 80 over 16, which therefore then works out nicely to be equal to negative 5. All right, so we have our values of A, we have our value of H, and we have our value of K. We can therefore draw a conclusion that 4x squared minus 24x plus 31 is exactly identical to, say here, A is 4, open bracket, say here, x plus H. In this case here, H works out to be a negative 3, so this is going to change from being a plus to a minus, so that's going to be x minus 3, and that's going to be all squared, and K then works out to be negative 5. Beautiful. So that is in fact our answer then for completing the square. All right, really nice. All right, now it then goes on then to say here that on the axis below we are to sketch the graph of what we've just calculated here, indicating the coordinates of the maximum point and maximum or minimum point and the y-intercept. So one thing we know for certain then is that it's a sketch, so it's not going to be completely accurate. But what we know for certain is that the y-intercept is in fact, say here, 31, because the y-intercept is always represented by, say here, C. So let's just make, say here, a little sketch. Let's just assume that 31 is all the way up here on the y-axis. All right. So that's the y-intercept. And we know for certain then that we know the x-intercepts. Then we need, these are the things we need to sketch a graph. We're going to need the x-intercepts, or what they say, the roots of the equation. We're going to need the minimum value, the minimum or maximum value depending on the equation, and we're going to need, say here, the turning point. All right, and these can be obtained from, say here, the equation that we just created, the expression that we just created. So we know that the turning point is going to be, say here, negative h. So the turning point here is going to be negative h comma k, which in this case we know that negative h is going to be the negative of what we had calculated for h. So negative h is going to be positive 3 and k is going to be negative 5. We know that for certain, so we're going to find 3, negative 5. So assuming that this is 1, this is 2, this is 3, and then this is 1, 2, 3, 4, 5. We know that this is 3, 5, so we are going to be somewhere right here. All right, so this is going to be 1, 2, 3, and negative 1, negative 2, negative 3, negative 4, negative 5. We know that for certain. So remember guys, it's a sketch. So this is going to be our minimum point here. Okay, minimum point, so min point. And then of course that's going to be our, well, the minimum point is -5, but the turning point is at -3. The turning point is at 3, negative 5. So I know that this is my axis of symmetry. This line here cuts my graph into two halves. All right, and then now I know that it's going to cross the y-axis up here, so I'm going to do something like this then. Let's see here. We're going to just draw a line through 31. It's going to come down, but hold on guys, I think we need to calculate the roots of the equation. I need to know what values of the x-axis it went through. So we can actually do this then. Let's do some calculation over here. We can solve this equation here. We can have, say here, let's solve this equation for x minus 3 all squared minus 5. Because we want the roots of the equation, we know it's going to cross the x-axis when y is equal to 0, when the equation is equal to 0. So if you bring this 5 over here, we're going to have 4 open bracket x minus 3 all squared is equal to positive 5. And then of course we can divide both sides, say here, by 4. So we're going to have, say here, if we divide over here by 4 and divide over here by 4, we know that the 4 will cancel the 4. So we know we're going to end up then with, say here, just give me a sec guys. So when we divide both sides by 4, we know for certain that this 4 is going to disappear. So we're going to end up with x minus 3 all squared is equal to, say here, 5 over 4. All right. And then now from there, now we're going to find the square root of both sides. So when we square root the left, we're going to end up with x minus 3. And that's going to be equal to plus or minus 5 over 4. All right. We're going to square root both sides. So we're going to have x minus 3 is equal to the square, is equal to plus or minus the square root of 5 over 4. All right, because we square root both sides. So I think that's where I went wrong, guys. So now I'll end up with, say here, x is equal to positive 3 plus or minus the square root of 5 over 4. So 5 over 4, let's see here, shift square root 5 divided by 4, that gives me 1.1. So that's going to be x is equal to 3 plus or minus 1.1. So now I end up then with two solutions then. Let's go back up here. I do apologize for that, guys, because I completely forgot the square root. So that was just a mistake there. Right? I actually went ahead to look on Terry David's channel, and I don't think that he actually attempted this question. I think he skipped right over it. I don't think he saw the question. Anyways, we're gonna have, say here, and this is 3 plus 1.1. So that's going to be that x is equal to 3 plus 1.1, and then we're going to have x equals 3 minus 1.1. So this is going to be equal that x is equal to 4.1, and then x then is equal to, say here, 3 minus 1.1. We end up, say here, with 1.9. Let's see if this makes more sense for our graph. So that's 1.9. So then 1.9 would have been maybe very close to 2. So let's see, 1.9. So this is 1, this is 1.9, very close to 2. And then we have 4.1. That's odd. So this is 2, this is 3, this is 4. So it's out here somewhere, about here, somewhere there. All right, so if you're to sketch this graph, then it makes more sense then that our graph is going to look something like, say here, this. It comes through 31, comes through 1.1, comes right through the point here and bends and come right up like that. And that's going to be our sketch. All right, so this makes a lot more sense then. All right, even though my graph is not perfect, but you get the idea. You're going to be a lot better with this on the actual exam paper once you use your rulers and your freehand sketch. All right, beautiful. So that was the error, guys. All right, these things do happen when you're in exams, so you've just got to make the adjustment then. Now it says here that we're to state the equation of the axis of symmetry. The equation of the axis of symmetry can be found right here in the middle here. So that's x minus 3 is equal to 0. So that's x minus 3 is equal to 0. The axis of symmetry equation is that x is equal to 3, which we had already established in this blue line here when we constructed it. That is the axis of symmetry. So that there ends that question pretty good. All right, so I tried to do that research on Terry David's channel. I think that he may have skipped it over, not seeing that particular question. So hopefully this one helps you then. All right, so we're going to be moving on to question 9. Say here KLM and NR points on the circumference of a circle with center O. XY is a tangent to the circle at K. LKY is 48, so let's look for that. That's LKY is 48. That's that angle there. Beautiful. We have that. MKO, that's MKO is 12. We have that there. Perfect. And angle XKN, that is XKN is 56 degrees. All right, so we have all of those measurements then. What are they asking us for is that we should find the value of angle KOL, giving reasons for each step of your work. So we're looking for angle KOL. So we're looking for this angle right here. All right. So as I look at this diagram here, the very first thing that I saw was that the line OK is a radius that is drawn perpendicular to the line, say here, XY. So right away I know that this is theorem number 2. If a radius or a diameter is drawn perpendicular to a tangent, then the point of contact forms a 90-degree angle. So right away then I can actually go ahead then and squeeze in and find all of this angle here inside here, because then I know then that this angle here, let's just shade it here, this angle right in here. So that angle then is going to be equal then to, say here, 90 minus 48 plus 12. That little piece right in here. No, well, in fact, better yet, since we're not really interested in the 12 is a part of our angle, I know right away then that I could find all of this angle right here by simply taking 48 away from 90. And then that works out nicely to be 42 degrees. They did say give reasons for your answer for each step of your work. So I know that a radius drawn perpendicular to a tangent equals 90 degrees. So that's reason number 1. All right, now that I know that this is 48, I automatically know that this is also 42 degrees as well, because of course, how do I know that that is 42 degrees? Because if you have this radius here OL and you have also this radius here OK, then I also know that radii of the same circle are equal. So I know again another reason for this is that OL and OK are radii pardon me here, I think I spelled the word radius, or radii of the same circle. That's what I know for certain. So OL and OK are radii of the same circle. Now if that's the case, then it means then that base angles are equal. It makes it an isosceles triangle. So therefore then angle KOL then can easily be calculated then by saying therefore angle KOL is equal to 180 take away 42 times 2. So that's going to be therefore equal to 180 minus 84. Okay, that's 42 here. So 42 times 2. Okay, so that's 42 times 2. So that's 84, and that's going to be equal to 96 degrees. So this angle right in here is in fact 96 degrees. And then of course the reason would have been that the sum of the angles in a triangle, we could see that adds up to 180, or we could see that they are supplementary. Okay, all right, so that is how we had to go about finding that. Again, I feel like Csec was a bit stingy on the marks. Could have given you about 3 or 4 because it did require a couple of different reasons. Let me know if you see another way to find that 96 degrees. That would be really, really good. All right, so now that we have that 42 degrees there, we have given our reasons. Let's go down here. It says that we should find the value of each of the following angles. Once again, I'm assuming that you should give reasons for your answer. Angle LMN. So the angle is located at the letter that is in the middle. So angle LMN, angle LMN. So that's L is here, M is here, and N is here. Angle LMN. Let's double check on that. Make sure that we have the right one. Angle LMN. So what we're looking for is angle LMN. We're looking for all of this angle here, angle LMN. All right, now the way to find this then is, if you notice that the points N, M, L, and K are all on the circumference, which basically makes this particular shape here what is known as a cyclic quadrilateral. And so one of the rules, one of the theorems for a quadrilateral inscribed in a circle is that the opposite angles are supplementary. So therefore then, let me just grab a couple of markers here just to highlight. I know right away that this angle right here is going to be this angle, and this angle here, they're going to add up to 180. Now, the only thing that I don't have here is the angle in this section here. And I know that all the angles at a point on a straight line measures 180. So if I can add the 56 and the 48 and take it from 180, I would therefore get the angle that is right here. All of this angle right in this section here. And then of course this angle that I've now calculated plus the unknown angle here equates to 180. So let's get to that then. First thing we need to find is that angle L, angle NKL. So let's go down here. So start off by saying angle NKL plus angle LMN equals 180 degrees. That's according to the cyclic quadrilateral theorem. So cyclic, pardon me here. So that's CYCLIC, cyclic quad theorem. Okay, so the opposite angles are supplementary. So if I can set out then to find angle NKL, so let's go here, angle NKL, so that's NKL, I can go ahead then and add 56 plus 48 and take that from 180. So then this is going to be equal then to that angle NKL is equal to 180 minus 56 plus 48. So grab our calculator here. That's 180 minus 56 plus 48. That okay, hold on. 56 plus 48, and we're going to take that away from 180. We're going to end up, say, here with 76 degrees. Then, so that's 76 degrees here. And so from there then, we can just punch this 76 degrees here. So that's 76 plus angle LMN, and that's equal to 180. So if we subtract 76 from both sides, we find here that LMN is equal to 180 minus 76. That works out to be 104 degrees. All right, so that is what you had to go through. It says 1 mark here, so maybe I didn't need to do that much work, but that's what I'm thinking about here. That's how we'd find that angle. That's the only way that I'm really staring at the diagram, and that's the only way that I'm seeing that we could find all of that angle there. All right. I don't really see any other way. Looking, guys, let me know if you see another way, but that's the very first way that I saw. Right, it's 1 mark, very stingy I think, but it's okay. If you get your answer, that's how it works. Angle KLO. So let's go again then, angle KLO. Let's kind of clear up this diagram a little bit here. Let's just leave it at that. So we're looking for angle, say here, KLO. Let's have a look at where that is, angle KLO. So that's K down here, L here, and O. Okay, so we were fortunate enough to find it already. That is in fact 42 degrees. All right, so we know that KLO is 42 degrees. And we already established that the reason why that is 42 degrees is simply because you could see that the triangle is isosceles, so these angles are equal, or you could just say that radii of the same circle are equal. All right, and then say here we have MLK. MLK then is, let's scroll up here, MLK, guys, let's check it out. MLK, it would be all of this angle here, right here, all of this angle here. So that means we need to find this little piece of angle inside here. All right, so now to do that then, oh, I already know. Okay, all of this angle here. Well, I know for certain that this angle is 48 because the angle that is outside of the angle that is between a tangent and the chord is equal to the angle that the chord subtends at the circumference. So I know that this angle down here is equal to this angle up here. So that's 48. And I could also find this little piece of angle inside here, because I could therefore then add, say here, I could say 90 minus 48 plus 12. So 90 minus 48 plus 12. So that's 90 minus 48 and 12. That's about 60. So that's equal to, say here, 30 degrees. So I know that this is equal to, say here, 30 degrees. So this little piece of angle right in here is 30 degrees. And so now that we have this angle of 30 and I have this angle of 48, all of this angle can then by adding 30 to 48 and taking that from 180. So let's go down here. Bunch of steps for that question, guys. So now we end up that angle MLK is equal to 180 minus 30 plus 48. So that's 180 minus 78, and that's equal to 102 degrees. All right, and the obvious reason would have been that the sum of the angle in a triangle are supplementary. Okay, that's the reason for that. Obviously we'd have to put the other calculations for the pieces of angles that you found. That is going to be 90 minus 48 plus 12. That would have calculated the angle that we found here, this little piece of 30 degrees right here. And then obviously see here, you would also show the working out for the angle that we found to be 48. So that angle of 48 degrees was because the angle was subtended by the chord there. So you'd have to write a couple of statements then. Maybe I see here that it's only worth 1 mark, so maybe we don't have to write that much reasoning. All right, so this is the analytical part of it, guys. So K and M, it's a tricky question though. K and M, so K and M, so K and M, this angle up here, once again it is opposite to the angle down here that we just calculated here for 102. So we know that opposite angles in a cyclic quadrilateral are supplementary. So we know right away then, very similar to example number 2, question number 2, we know that K and M, that angle is going to be equal to 180 minus 102, right? This 102 that we just calculated here, and that's going to be equal to, see here, 78 degrees. Again, the rule is opposite angles in a cyclic quadrilateral are supplementary. Okay, supplementary. All right, so hopefully you guys got that. Think I may have went a little bit overboard with the statements, but a lot of information here that you can actually learn from this particular topic here. All right, so we've gone over a little bit over an hour. I'm going to pick up in part 4. We're going to be finishing up here part B of trig, and we're going to dive off into, say here, the vectors and wrap that exam up, and also the matrices here. All right, so thank you guys so much for watching this yet another upload for the past paper, and I hope that it was helpful in some way, shape or form. Let me know your thoughts in the comment section below. Until then, take care. Bye bye.